Have you ever just stopped and wondered, how did we get here? From simple calculators to the powerful AI we have today, it definitely wasn't some overnight explosion. It was a long, fascinating journey. And today, we're going to walk through it, one breakthrough at a time. Assalamu alaikum and a very warm welcome back to Digital Future AI School. We are so glad to have you here. Now, this is episode 2 in our series, and we are continuing our deep dive into the incredible history of artificial intelligence by looking at chapter 2 of the fantastic book, AI, Your Smartest Partner in Life and Work, written by Mr. Zahir Ahmad Mir. It really does a masterful job of laying out how AI evolved from just a simple idea into the absolute force it is today. And as the book points out so well, AI didn't just appear out of thin air. Its story is one of decades of scientific research, countless experiments, and this slow, steady effort to teach machines how to think. So to really understand today, we have to go back to the very beginning. Okay, let's dive into this. Our story begins not with a computer chip, but with a single revolutionary question that honestly changed everything. This simple but incredibly profound question was posed way back in 1950 by the brilliant British mathematician Alan Turing. He wasn't just thinking about computation, he was imagining a future where machines could actually possess intelligence. This was the spark that ignited the entire field. And to answer his own question, Turing came up with this really elegant idea, the Turing Test. The concept was pretty straightforward. If you were having a text-based conversation and you couldn't tell if you were talking to a machine or a person, then that machine, well, it could be considered intelligent. It was such a practical way to define a huge philosophical idea. And this just shows you how powerful that idea was. Only 6 years after Turing published his paper, a group of researchers gathered at the Dartmouth Conference, and it was right there that they officially coined the term artificial intelligence, giving a name and a formal discipline to Turing's dream. So, with the field established, how did these early pioneers actually try to build thinking machines? Well, their first approach was very direct, based completely on logic and rules. This era was dominated by what's called symbolic AI. For nearly 50 years, AI was basically like a cook with a giant, meticulously written recipe book. You had human experts writing thousands and thousands of explicit if-then rules. The machine would encounter a problem, find the right rule in its book, and then just execute it perfectly. But this approach had a fatal flaw. I mean, the real world isn't a simple recipe book, right? It's messy, it's unpredictable, and it is full of situations you can't possibly write a rule for. These systems were brilliant at defined tasks, but because they couldn't learn or adapt, they kind of just shattered when they were faced with real-world uncertainty. So the crucial point here is that this first rule-based approach eventually hit a wall. All that initial excitement faded, funding dried up, and the field entered a period that's now known as the AI winter, a time of widespread disillusionment where progress just seemed to stall. Now, to break out of that winter, a major shift was needed, and it came from a completely new and, frankly, radical idea about how to create intelligence. This single sentence just captures the revolution perfectly. Researchers realized, hey, what if we stop trying to handwrite the recipe book? What if instead we just give the machine thousands of examples and let it figure out the patterns for itself? This, my friends, was the dawn of machine learning. This slide does a fantastic job of contrasting the two eras. Symbolic AI was top-down. Humans gave it the rules. But machine learning is bottoms-up. It learns from the ground up by observing data. The analogy just shifts beautifully from a cook who follows a recipe to a chef who develops a palate by tasting thousands of ingredients. And this new approach is what made AI truly useful in our daily lives for the very first time. You know, that recommendation engine that suggests movies you might like, the spam filter in your email, or even those early voice assistants on your phone? Yep, all of these were powered by the breakthroughs of the machine learning era. So, why is this history so important for understanding the powerful generative AI tools that you use right now? Because today's AI stands on the shoulders of all these previous eras. This whole journey shows us that AI isn't a single invention, but a series of evolving ideas, with each one building on the last. It began with Turing's big philosophical question. Then the age of rules built a foundation, but also showed us the limits. And finally, the breakthrough, enabling machines to learn for themselves, that unlock the potential that we are all seeing realized today. This entire history, from the Turing Test to symbolic AI to machine learning, has brought us right to this moment. It created the foundation for today's incredible systems. Which leaves us with one final, very exciting question to think about. If these eras built our present, what will the next era of AI, future AI school? It's great to have you here. This is episode 2, and today we're exploring chapter 2 of the fantastic book, AI, Your Smartest Partner in Life and Work, written by Mr. Zahir Ahmed Mir. This book really charts the incredible story of AI's transformation, and it's going to be our guide for this journey. So let's kick things off with the big question, right? In just over a decade, AI went from this niche academic field to something that's literally your everyday partner. How on earth did that happen so fast? I mean, it feels like just yesterday, AI was something you only saw in sci-fi movies, and now it's everywhere. Well, the answer isn't one single event. It was actually 3 distinct, totally revolutionary leaps. Okay, so that brings us right to our first great leap. This is where it all started. You can think of it like a spark, a single moment that just ignited the entire modern AI revolution. And that spark was the arrival of deep learning. Let's rewind to 2012. So in the world of computer science, there's this big competition for computer vision. A new neural network model called AlexNet shows up, and it doesn't just win. No, it demolishes the competition. The margin was so huge it had never been seen before. To put that into perspective, this wasn't like a runner being a little bit faster. This was like a Formula One car showing up to a foot race. Everyone just stood there and realized, oh, the rules of the game have just completely changed, forever. So what was this crazy new technology? Well, it was deep learning. And here's the best way to think about it. Imagine you want to teach a computer to recognize a cat. The old way, we had to sit there and manually write code for every little rule. If it has pointy ears, if it has whiskers, if it has a tail, it was super clunky, and honestly, it didn't work very well. Deep learning flipped the script. Instead of telling it the rules, you just show it millions and millions of cat pictures, and it teaches itself what makes a cat a cat. It learns the patterns all on its own, and it does it way better than any human could ever program by hand. And that was the absolute game changer, because suddenly we had a system that could scale. The more data you gave it, the more computing power you threw at it, the smarter it got. It wasn't long before it started outperforming humans in all sorts of pattern recognition tasks. And this is the key thing to remember. That one capability became the foundational building block for pretty much all the modern AI we use today. So you see, this wasn't just some boring academic exercise. Nope. This was the moment AI literally leaped out of the textbooks and the labs and started showing up in your life. We're talking about things you use every single day, like photo tagging on social media, the voice assistant on your phone, even super advanced medical diagnostics. All right, let's move on to the second leap. So, AI could now see patterns better than we could. That's huge. But the next question was even bigger. Could it strategize? Could it actually outthink us? And to find out, researchers decided to put AI to the ultimate test in the world's most complex and strategic games. Now, to really get the scale of this challenge, let's just compare 2 games for a second. We all think of chess as this peak of human strategy, right? Well, the ancient game of Go is on a whole other planet. I mean, get this. There are more possible moves in a game of Go than there are atoms in the entire known universe. I'm not kidding. It's so complex that for decades, everyone thought that the kind of intuition and creativity it takes to play, well, that was just going to be forever beyond the reach of a machine. And then, 2016, the impossible happened. An AI from Google DeepMind called AlphaGo sat down to play against the world's greatest Go player, and it won. This was a massive, massive deal. It was a true watershed moment that proved an AI could master a game that we all considered the absolute peak of human strategic intuition. But here's the thing. AlphaGo wasn't just a lucky shot. It was the start of a tidal wave. Just 1 year later, an even better version, AlphaZero, taught itself how to play chess, Go, and another complex game called shogi, with 0 human input, and it became a best player in history, like overnight. Then it moved on to conquer crazy complex video games like StarCraft 2, and even mastered the human art of bluffing and poker. One by one, the domains of human strategy were just falling. Look, the really important point here isn't just that the AI won, it's how it won. It was making moves that the grandmasters, people who've dedicated their entire lives to these games, were describing as beautiful, creative, even alien. It wasn't just playing better, it was playing differently. It was like it had discovered a new color that humans couldn't see. The AI was coming up with strategies that no human had ever even imagined. It was demonstrating a totally new kind of creativity. Okay, so let's recap. Deep learning gave AI the power to see patterns. Superhuman AI gave it the power to strategize. So what happens next? What happens when you take those incredible new powers and apply them not to pictures, not to a game board, but to the single most complex and powerful thing humans have ever created, language itself? Well, that's what brings us to the third and final leap, the one that put AI in the hands of everyone, the LLM transformation. Yeah, you've definitely heard these names before. We're talking GPT, Claude, Gemini, Llama, the whole family. These are large language models, or LLMs for short. And what they are these massive AI systems that have been trained on, well, basically the entire internet, all the text, all the code, and that training lets them understand and generate language in a way that feels incredibly human. And believe me, this was maybe the most important shift of all. Because before LLMs, AI was a really powerful tool, but it was a specialized one, kind of like an electron microscope. You needed to be a highly trained scientist to even use it. But with LLMs, AI completely changed its job description. It went from being a specialist tool to being an intelligent assistant for everyone, an assistant you could talk to, just by typing. And just think about what this assistant can do. We're not just talking about finding facts on Google anymore. This is something that can help you write a tough email, it can help you code, it can explain a super complex topic like you're 5 years old, it can brainstorm ideas with you for a new project, or summarize a 50-page report in seconds. It truly became a partner for thinking and for creating. Okay, so let's tie this all together now. AI in your hands. This is the result of those 3 great leaps. The thing to understand is, these weren't 3 separate random events. Not at all. They were a connected chain reaction, with each leap building directly on the one before it, all part of one single story that ends with this incredible technology right in your hands. So here's that journey to your pocket, broken down into 3 simple steps. Step 1, the spark. Deep learning gave AI the ability to understand massive amounts of data. Step 2, the proof. Superhuman AI proved that this ability could lead to truly creative, strategic thinking. And finally, step 3, the connection. LLMs created that simple, user-friendly interface that made all of that power accessible to you, me, and everyone else. And that right there is the ultimate takeaway. This is the big so what. For the very first time in history, the immense, world-changing power of artificial intelligence isn't locked away behind the doors of a research lab. It's out in the open, it's available, and it's ready for literally anyone to use. So think about it. Those first 3 leaps took AI from the lab and brought it right into our daily lives. They completely reshaped our world in just a little over a decade. It really makes you wonder, doesn't it?
By the visionary Mr. Zahir Ahmad Mir. Today, we are tackling Chapter 2, and it's called The Acceleration. And let me tell you, that name is no exaggeration. This is a mind-bending look at the sheer, breathtaking speed of change we are all living through right now.
So, how does the author kick things off with this incredible statement? This period is defined by the most powerful scientific acceleration in human history. Just let that sink in for a moment. Not just a big change, but the most powerful scientific acceleration ever. Now that's a huge claim, and to really make us feel that, the book starts with one stunning, almost unbelievable example.
It all starts with this one single achievement from the world of biology, something so massive it's actually kind of hard to wrap your head around. It all boils down to one absolutely gigantic number.
There it is, 214 million. Okay, so what is that? That's the number of unique protein structures predicted by just one AI system, Google DeepMind's AlphaFold 2. But you know what really makes that number so incredible?
Well, check this out. In the entire history of science, think about all the scientists, all the labs, all the decades of painstaking work, we humans managed to map about 150,000 protein structures. A huge achievement, right? Well, this AI, it did 214 million of them in just 2 years. That's not just an improvement. That completely shatters the scale of what we thought was even possible.
And look, this isn't just some abstract number for scientists to get excited about. This has real-world, life-changing impact. We're talking about radically speeding up the development of new drugs, creating better vaccines, and discovering new treatments for everything from cancer to genetic disorders. That's what this acceleration actually looks like in the real world. So the big takeaway here is that our relationship with technology has fundamentally changed. AI is no longer just a fancy calculator or a database we look things up in. It has become an active collaborator in discovery, a true scientific partner.
But believe it or not, as world-changing as that is, it's only one piece of the puzzle. The book argues the next phase of this acceleration is AI moving out of the science lab and walking right into our everyday work. And this is happening with the arrival of a brand new concept: the AI agent. Now, you need to forget what you think you know about smart assistants. An AI agent is something totally different. It's an autonomous system designed to execute complex, multi-step tasks. You can think of it really as a digital worker. So how in the world do they work? The book offers this really great, simple metaphor. We are giving AI digital hands to click, type, and execute commands. We're giving it digital eyes to browse the web, read documents, and analyze what it's seeing. And crucially, we're giving it a memory to learn and perform truly complex jobs. Okay, so with these new hands, eyes, and memory, what can these agents actually do? Well, almost any digital task you can imagine. We're talking about conducting deep research online, writing software code, analyzing huge documents, filling out complex forms, even creating entire designs and presentations. They can operate on their own from start to finish. This is literally the beginning of automated digital labor. This incredible leap in capability, it naturally leads to the big question, right? The one that's been the stuff of science fiction for decades. Are we getting closer to artificial general intelligence, or AGI, an AI with human-level reasoning? Is that just a fantasy, or is it becoming reality?
Well, the book's answer is direct. It doesn't pull any punches. AI is not a fantasy. The author argues this is no longer a philosophical dream for the distant future. It's being approached as a practical engineering problem for right now.
In fact, the very technologies we've just been talking about are the foundations. These powerful reasoning models, the systems that can understand text, images, and sound, and the autonomy of these new agents, these are the actual building blocks for the AGI of tomorrow. Just take a look at this timeline. You can see the long, steady progress for decades. And then, look what happens around 2020. The pace of change goes almost vertical. The era of large language models and agents represents an explosive acceleration unlike anything that's ever come before it. And that right there is the core message of this entire chapter. The AI we have today is a fundamentally new kind of technology. It is more general, more capable, and evolving faster than any tool in human history. Period.
So, this incredible acceleration brings us to a critical question for our own lives. If AI is becoming this powerful, this fast, what does that mean for us? The next chapter of the book tackles that head-on, asking, why is AI the universal skill of the 21st